Measuring angles and arcs. If you didn't get that written in, try and get that written in right now. It goes to the 128 first, Nemo. Alright, we have kind of a lot of different vocabulary words. We have 5. We have 5 vocabulary words today. So much. Okay, our first vocabulary word is a central angle.
Central angle. Where do you guess the central angle is going to be? In the middle.
In the middle. So it's an angle with a vertex at the center. An angle with the vertex at the center. So the part where we look at the actual angle is at the center. So what are some angles you see in this circle that are central angles? 2, 4, 3, and 1. All the numbers are here. If we put a letter in the middle, we could name them as like K, A, W if we put an A there, but we don't have a point there. What are you doing? Okay. All right. What do we know about all the sets in a circle? What do they have to all add up to? 360.
No. I have to go wash though.
I think you guys get let out at 1:30.
I have to wash before.
Yep, so does everyone. So that's why you have until 1:45.
Oh.
You know what I'm saying?
Yep.
Okay. All right. Next up, we got arc. An arc with a C, not with a K. So an arc, it's like an arc welder. Make an arc. Do you know how to arc weld, Miss Ryder? No. All right, an arc is a part of the circumference. Okay, so we're going to be traveling along the outside for arcs. We might go all the way around. It could do the whole thing, but then it would be a circle. So an arc would be like if I started at W, where could I travel to? P. But if I travel to P, I'm going to travel along the outside of the circle. That would be an arc. Okay, or I could go W to P, and then I could keep going on to B, and then end up at K. Any of those would work. So the way that we notate that is if I wanted to go W to K, W, P to K, is I'm going to go W, P, K. We use those capital letters for the points. But to show that we're going around the circle, it's an arc, we do a little arc symbol above it. It's not a straight line, it has to have that like curve. So there are 3 big types of arcs. Okay, one way is the minor arc.
What could you guess about a minor arc? Good.
Good, it's small. So a minor arc is the shortest path from point to point.
So that doesn't necessarily mean it's the shortest length or the shortest angle. It means the shortest path we are traveling from one point to another.
I'm going to leave a little bit of a space here, and I'm going to do it right underneath it. So leave a space here for an example. If you went to a second line, you could just do the example right after. But I filled up my whole line. So if we have a minor arc, the other type is called the major arc. If minor is the shortest path from the point to point, major arc is the longest path.
Now again, we can't just automatically say, okay, BK is the major arc. because it's not really just about the space. It depends on what point we're going from and what point we're going to that determines the major or the minor.
So let's pick any point to start at. What point do you guys want to start at?
K.
K. All right, we're going to start at K. And where do you want to end at? B? Okay. What's the quickest way to go from K to B around the circle? Do I want to go to the left? Do I want to go clockwise or counterclockwise? Yeah, clockwise. So our minor arc, yep, you're good to go now. Minor arc would be this K to B. And when we write a minor arc, we only need 2 points. We can go K. Okay, when we notate it in minor arc, we only need 2 letters, K to B. Because if I told you guys that we are going to walk to the Quick Trip from here, would you guys go around the school and then to the Quick Trip? Or would you just go straight to Quick Trip? Yeah, right? Same thing here. If I tell you to go K to B, are you going to go around the circle to B or just go straight to B? You're going to go the shortest way. You're not going to go extra, right? Okay. Well, then you're major. All right, so each arc, there are, for each point, 2 points, there are 2 arcs we can connect them with. There's one that's a minor arc, and there's one that's a major arc. So what would be the major arc for K to B? Where would I need to go the long way around? K to what? To W, to P, to B. So for major arcs, we use 3 points. The first point has to be where are we starting. The last point has to be ending. And the middle point has to be something in between those. What's one of the points we pass? So if we go K to B and we go counterclockwise, what's one of the points we pass? We could do P, K, P, B. Or we could do K, W, B. But we always only points. Okay, those are both K, W, P. But this poses a dilemma. Because I said for every 2 points, there's a short way and a long way around, right? Can anyone find 2 points that no matter which way you go, it's the same amount? There is no short and long way? WB. If I start at W and I go to B, is it shorter to go WPB or is it shorter to go WKB? There's not. They're the same. Okay, so because they're the same, there is no major or minor arc for them. We call that a semicircle. Okay, and semicircle is exactly half of the circle. So in our case, we said it was W to B. So one semicircle would be W to P to B. Or we could go the other way, WK to B. I'm just going to mark just one of them, otherwise it's going to just look like I circled the whole thing. Okay, and for a semicircle, it's WPB. Or we might just say WB, because when it's a semicircle, it doesn't always matter which way you run. It's going to be the same amount. Okay, any of you do that when you were little with like a little brother or sister that was like, you run that way, I run this way. Meet up in the middle, right? No? I don't know. We used to run around our house a lot when we were kids. We didn't have a lot to do. We just ran circles. I don't know. All right. So, those are our 5 major keywords for today. We're going to be doing those continuously. We're going to do some central arcs, though. Or it's not central arcs, central angles. And the measure of an angle is the same thing as a measure of an arc. So if I wanted to know what is the what is the measure of the arc, WP, that's really asking what is the measure of the angle at 3, because that is what connects W to P. All right, so for this one, if you didn't glue this one in, this is that 128. I want to find all the other essential angles. That's my goal. I know that this J is 128. The arc JI is 128, or I could say the angle JGI is 128. How could I find another angle? Which angle do you guys want to find next? The one above it, the one kind of below to the left, or the one across? What? Across. How can we find the angle that's across from 128? This is really pulling back to like trimester 1. Not corresponding. They are going to be congruent though. What? You had it. No, you had it. You had it. You had it. Oh my gosh, you had it. Okay, someone else. What do we call those angles that are across from each other that are congruent? Vertical. Vertical angles are congruent. So we know if this is 128, then this is 128. Then, what? 128. That's my 8, Goofy. All right. Then how can I find these other angles? Subtract them from what? Sure, I could do 360 minus 128 minus 128, and then I'd have to split that into 2 because I know they're equal parts. Or I can think about how there's this diameter. We know that this is a diameter of the circle, H to J. That's a semicircle. So a semicircle would make 180. So if I know that's 180, I can take 180 minus 128, and what would that equal? I don't know. Why did I ask you? 180 minus 128. I did it on my calculator, sorry. 52. So we know that this is 52, and this is 52, because we know that those are the same, because they're vertical angles, they're across. All right, we're going to jump down to the bottom problem. There's one more thing we're going to be doing today, so don't get too excited that we're like done with notes. We're not quite done. We're going to go back. Sorry. I know it's exciting. All right, so on this one, we know that this one's 59 degrees. What other angle do we know? We know the measure of arc GK or GLK. What's that going to be? 59, because they're across from each other. So they're vertical. What else do we know? Yep, the measure of arc IJ is 90 degrees. How did we know that was 90 degrees? Sorry. It's got the little box thingy. Does that mean HG is 90? No. But they're across from each other.
But it's longer than the other one.
Yeah, they're not. It's not created by two straight lines where H to K and IG were the only two lines. This one's created by kind of a couple lines. So what's the next angle that you guys want to find? Do you want to find HG or JK? Okay, HG. How could we find HG? $180. Which 180 are you using when you think of that fatu? Are you thinking of G to I or K to H? Are you thinking HK is the 180 or IG? IG? Okay. So we're thinking this is our 180. So we're going to take that 180 minus the 59. And we get 121. How can we find this last angle that we're missing? Yep, we could do 90 plus. Yep. Minus, how much is that part of the circle? 180. We could do it that way. We could look at that half circle. Or we can think of the whole circle. If we didn't have a 180 and we were just missing one part, what number would we start at with the whole circle? 360. That's one I'm going to write down. If you want to do it a different way, that's fine too. I just wanted to note it in our notes. Note it in our notes. 360 minus, what's one of the angles? 90 minus 59 minus 121 minus 59. $180 when you know you have a half circle. When you know you have a diameter, you use $180. $360 if you want to use the whole thing.
And for this one, Patrick, we could have used 180. We're just showing you that there is another way as well. 31. You could have used 180 as well. Yep.
31, you're right. I did it wrong. I typed it in. 31. Nice job, Jackie. So 31 degrees. So there's actually quite a few ways you could do it. You also know that this top one is 90, so that means this bottom one has to be 90 because it makes 180. So you could do 90 minus 59. Lots of ways you can get that same answer. All right, we have one more vocabulary word to actually add in. Okay, I have a weird amount of space here that I actually left space for it. I should have told you to leave 3 lines. If you didn't leave 3 lines here, you can just write it underneath. I need about 3 lines for this. So if you don't have 3 lines, you could either erase and move that down or right here. Okay, we're going to do an arc length. And an arc length is the actual distance of the arc. So how long is it? Not necessarily what's the degree, how much are we turning in the circle? How long would we have to walk if we walked that on the outside of the circle? And there's a formula for that. Okay? If we walked the whole way around the circle, how much is that? Remember
Degrees.
how many degrees is in the whole circle? 360. Did you say 360? Okay, 360. I thought you said 160. Okay, and then what's the length of the circle all the way around? What do we call that? Circumference. And how do you find circumference of a circle?
We did it in our warm-up a little bit. What are some options to find circumference?
Pi times what? Diameter? Pi times diameter, or 2 pi times radius. So if I want to do pi times diameter, I don't want to do the whole 360 though. So I'm going to take just part of the 360. So x over 360, and that x stands for our degrees out of 360. And then I can multiply it by our pi times diameter. Because pi times diameter is the whole circle. And then this is telling us how much of that circle are we going to use. That's one formula. What's the other formula going to be? X over 360 times, what's the other way to find circumference? 2 pi times the radius, 2 pi r. So kind of based on what you're given, you can either do pi times diameter or 2 pi r. So it's just the circumference. Okay, to find arc length, anytime we use length in math, we use a cursive L, apparently. I was told that last class by a student. I was like, why do we use a cursive L? And they're like, because it's length. I was like, oh, you're right. Okay, whenever we do length, we use this cursive L. It's kind of a loop-de-loop, but it's an L. Okay, if you just want to use a L, we don't use capital L usually. And a lowercase L looks like 1. So, all right. So in this problem here, this is kind of the first part. All right, so in this problem, we're going to say that we know GI equals 4 centimeters. I want to know what is the length of IJ, of arc IJ.
So, I'll break that down.
All right, so when I look at IJ, I want to think what is the degree, or what is that measure of the angle created by IJ? 128. So we're going to take 128 over, this is how, when we're thinking how much of the circle are we using. So it's 128 degrees out of how many degrees total?
What's the whole circle?
360 times, and then we're going to use our circumference formula. So we know GI is 4. Is GI a radius or is GI a diameter? Yep, GI is a radius. So do we want to do pi times diameter or 2 pi r? 2 pi r. So we're going to say times 2 pi times, what is our radius? 4. For these ones, I really like to use Desmos because Desmos is going to be able to show us all of our work, especially if we get something goofed. So 128 out of 360 times 2, and then the pi is right here. It's right next to that 4. Pi times our radius of 4. If I want to round to the nearest hundredth, 2 decimal places, why is it going to be 94? The 6. The 6 tells us to round the 3 up. So 8.94. And what are we measuring in for our length? Centimeters. All right, one more and then we are done with notes. I'm going to go to that bottom example. Okay, if you missed a little bit, jump to this bottom example with us, and then you can copy notes. All right, in this one, we know HK is 12 inches. And we want to know what is the length of HKJ, that arc. So what point am I going to start at in my circle when I do that arc? What's my starting point? H. What's my ending point? J. So I have H and J. Am I going to go towards the I or towards the G? What's the middle point here? K. So I want to go towards the K, which is really towards the G. I tricked you. Okay. Is that a minor, a major, or a semicircle? Major. It's more than halfway across. It's a long way. So as I figure out that angle, I want to put all those angles together to figure out how much is it from H to J going in that direction. So I'm going to take 121 plus what? 59 plus 31. $121 plus 59 plus 31, so 211. So for the amount of the circle that we're finding 211 degrees out of how many degrees total? 360 degrees. And then we need to multiply that by our circumference. So with our circumference, we pi r, or pi times diameter. So what part are we given? We know HK is 12. Is HK a radius or is HK a diameter? H to K is a diameter. So should I do 2 pi r or pi times d? Pi times d. So pi times, what's my diameter? 12. If you wanted to do the 2 pi r, that would be fine. You would do 2 pi times, what would the radius be? What's half of 12? 6. So you could do 2 times pi times 6. You'll get the same thing. But it's just really the length you have to decide, was that a radius or a diameter? Okay, again, I like to use my Desmos calculator. Times pi times 12. So I have 22.09. Sorry, you couldn't see that apparently when I typed it in. 0.9, but the next number is 5. So do I want to keep it a 9 or round up to 10? Round up to 10, so it's going to be 22.10, which would be the same thing as 0.1. And we're measuring in inches. Okay, so the 3 parts of your homework today. The first part is going to be asking about major, minor, and semicircles. The second part is going to be asking you to find these central angles, knowing that they all add up to 360. And then the last part is going to ask you about arc lengths. Okay? This is on Schoology.